Hello and welcome to Geometry today. We are going to go through the logic assessment review, and your assignment today will be to actually go ahead and complete this informative. So you should get lots of help and tips and tricks as we go through this. Okay, so the first section is matching vocabulary terms to their definitions. So let's just go down the list and make sure everybody's comfortable with what they all are. So the angle addition postulate, that is where we have two angles that are side by side. Okay, and then the sum of the whole angle here is the sum of the two parts. So if this is angle 1 and this is angle 2, and we call the whole angle angle 3, the measure of angle 1 plus the measure of angle 2 gives us the measure of the big angle. Okay, biconditional, that is, let me change colors, that is where we use this symbol, the if and only if symbol, and this is where the converse and the conditional are both true. Converse and the conditional are both true. Okay, the segment addition postulate, very similar to the angle addition postulate, where we have two segments. We can call this segment 1 and this one segment 2. And then the sum of the whole thing, let's call that segment 3, is the sum of the two parts. So the length of segment 1 plus the length of segment 2 gives us the length of the whole thing, number 3. Converse is when we take the conditional statement and we flip it. And we can write that in the form of if Q, then P. Our hypothesis is what comes after the if, and we can also denote that by P. Midpoint, if we have a line segment, let's call this A and B, and then our midpoint C is exactly halfway between A and B, and the two segments AC and CB are congruent or exactly the same. Okay, it's a lot of red, let's do some blue. Okay, contrapositive. So that's again where we take the conditional statement and then we flip it and we negate it. So in terms of P's and Q's, it is not Q. If not Q, then not P. Supplementary angles are two angles that add up to 180 degrees. A counterexample is an example that proves a statement false. All right, let's do some green for the last few, just to make it pretty. Okay, inverse, that is when we negate a conditional statement. So it would be not, if not P, then not Q. Complementary angles, they add up, two angles that add up to 90 degrees. Conditional, that is your original statement, a statement that's written in if, then form. Remember, we kind of going to put up P here and our Q here. And finally, our conclusion. Our conclusion is the part that comes after the then part of the statement, also denoted by Q. Okay, so hopefully that's a good reminder of what all of these terms mean. Right now, the calculation part. So I'm going to go ahead and just set these up, but let you finish them off as part of the assignment. So let's start with the segment addition postulate. Let's see what it says. We're given this figure and we're given the fact that DG is 60. So I always say that you should always put on all the information in your picture so that it's a little bit easier to figure out what you're doing. Okay, segment addition postulate says that if we add the lengths of DO and OG, then we should get the length of the whole thing, which is 60. So let's write that down. So DO plus OG will equal 60. And now we can just go ahead and substitute what we know. So DO is 4x minus 3. And we're going to add that to OG, tells us 2x plus 21. And that equals 60. So I'm going to leave it for you to go ahead, combine these like terms, right? We have x terms here, and we also have numbers here. So add them all together and solve for x. And that will be your first answer. And then to get DO and OG, let's set that piece up. DO is 4x minus 3. So when you know what x is, go ahead and substitute the number in here, and you'll come out with an actual whole number. And then the same thing for OG. OG is 2x plus 21. So go ahead and substitute x into here, and then you can calculate the length of OG. Okay, let's take a look at number 15. It tells us that point B, I'm not sure what those stars are, point B is the midpoint of line segment AC. Remember what midpoint means. It's exactly halfway between the 2 points. So that means we can write these little congruent marks on here. The length of AB is exactly the same as the length of AC. So we've got 5x minus 9 equals, because they're exactly the same, 2x plus 6. And there's no actual question on here. In your actual assignment, it says that you have to find the length of AC. So the first thing you'll need to do is calculate what x is. Then you will need to substitute x into 5x minus 9 to get the length of AB. And once you've done that, then the length of BC should be exactly the same, but you may want to substitute it, and just to make sure, you should get the same answer for both, and then just add them together to get the length of AC. All right, let's take a look at 16. So if ABC is a right angle, here's important information. ABC, angle ABC is a right angle, which means we can just write the angle, right angle notation there. That tells us, remember, a right angle is 90 degrees. So to set this up, the angle addition postulate tells us that the measure of angle ABD plus the measure of angle CBD must equal 90. So to set this up, we're just going to add these guys together. 40 minus 2x plus x plus 59 has to equal 90 degrees, the whole thing. And I will let you go ahead and calculate what x is. Same idea as the previous examples. Once you have x, you can substitute it into here to get the measure of this angle, and then you can also substitute it into here to get the measure of this angle. All right, 17, we have to find out what x is. Take a look at this. We've got two intersecting lines here, and we have angles on opposite sides. So these are vertical angles. And vertical angles are congruent, which means that they have the same measure. So this one is fairly straightforward. We can just set these two equal to each other and solve for x. So 4x plus 24 equals 7x plus 3. And I will leave you to do the rest of that. Logic statements. Okay, so for each conditional statement, remember conditional means it's written in if-then form. We have to circle the hypothesis and underline the conclusion, identify if it's true or false, and if it's false, find a counterexample. Okay, so the hypothesis is the bit that comes after the if, and the conclusion is the part that comes after the then. All right, so let's just write that conclusion. This is the hypothesis. Remember, this is also P, this is also Q. Okay, is the statement true or false? If today is Friday, then tomorrow is Saturday. Well, I'm going to let you figure out, is that true or false? Let's take a look at 19. If an animal is spotted, then it is a Dalmatian. So the hypothesis comes after the if. Right, this is the hypothesis, or it can also be written as P. And then our conclusion comes after the then. It is a Dalmatian. That's our conclusion. Or again, we could write that as Q. Is this statement true or false? If an animal is spotted, then it is a Dalmatian. Well, this is actually false. Why is that false? Well, if an animal is spotted, it doesn't necessarily have to be a Dalmatian. And a good counterexample might be a leopard, right? So that's spotted, but it's not a Dalmatian. You could always use cheetah, or perhaps even a giraffe might be spotted. So you've got plenty of choice here for a counterexample or one of your own. Okay, let's take a look. Almost done. Write the following statements. Conditional statement. If two angles are vertical, then they are congruent. All right, so here is your P, your hypothesis, and here is your conclusion, your Q. All right, so it's if P, let me write that as a, so we have if P, then Q. All right, so let's just go through. So the converse is the flip. So this will be if Q, then P, and you can just flip these two over. Inverse is when we negate. So this would be if not P, then not Q. And you can go ahead. If two angles are not vertical, then they are not congruent. And then the contrapositive is where we flip and we negate. We do two things. So we have if not Q, then not P. Hopefully you can figure out what goes where. Last question, what are the three undefined terms in Euclidean geometry? They are, let me get a different color, point, line, and plane. Okay, so point, line, and then a plane. Remember, a plane goes off to infinity in all directions. Okay, so hopefully that will give you some assistance with completing your review today. And that is it from me. If you have any questions, then please do email or join office hours if you want to ask something that takes a little bit more information than email. And good luck with your review.